Hello, everyone, and welcome to Simplified Network Automation with NetGrew. I'm your host, and today we decided to bring back Tony Dubiel. Tony, thank you so much for coming back. Principal Specialist Solutions Architect at Red Hat, Ansible, IBM, uh,
The
one
whole
of those.
conglomeration.
The whole, yeah, the whole thing. Tony, thank you so much for coming back. We have a fantastic session. People keep talking about AI, so I know you have like an AI Splunk Ansible event-driven architecture demo environment set up. So I'm really excited to see what you came up with. And yeah, welcome.
Cool. Yeah, thanks for having me. If you don't mind, I just kind of want to throw a couple slides out there just to
Yeah,
make sure that I don't forget like kind of the problem statement and challenges of what I'm going to demonstrate through in the live demo, but just to kind of give us a backdrop for that stuff before we get too deep into it.
yeah, no worries. Let's do that.
All right. And get rid of this. And hopefully you see a slide at this point.
Docs.google.com. Yes. Yep.
Okay, awesome. So again, just a little bit of background before we get into the demo, and a lot of this is just sort of like my own learning journey, trying to adopt AI, and some of the things that I've been doing from like not just a learning experience, but trying to help customers attack like different use cases and to use AI as a tool to kind of help them along and to solve some specific problems. So that's what these subsequent slides will kind of just talk through that quickly. And then I have a demonstration that'll, cover pretty much all the talking points that I have on the slides.
Mm-hmm.
So one of the problems or challenges that we have is there's so many observability tools, and I primarily focus in the networking space. So working with the NetOps teams, and there's a lot of really good tools out there that collect a lot of data, provide actionable insights that you can act upon. But because there's so much data, there's really like I guess a gap, if you will, on like the observability versus being able to respond to the remediation or to provide that fix, if you will. So we still kind of see a higher mean time to resolution because of just limitations with the team and human resources and things like that.
Mm-hmm.
So the solution here, this is kind of like the high level solution, and then we'll double click into it a bit more as we go through, is a goal to start to automate that troubleshooting so we can close the remediation gap.
Mm-hmm.
And in order to do that, there's, obviously a lot of controls that we need in place, and we need to, validate what this automation or this workflow will become. But at the end of the day, as we start to automate, more of the remediation, we can move quicker. And even if that's just like initially with like we call ticket enhancement, where we're not quite fixing the solution, but we're doing a lot of triage to make it a lot quicker to bring that human in the loop, so that they can provide that skill set that has the ability to troubleshoot. So on the Ansible side of things, we work along with a lot of the observability tools on the front end. So if you look at Ansible Automation Platform and Event-Driven Ansible, we're able to receive data. So as we're notified, as EDA is notified in different ways, because we have different source plugins such as webhooks and Kafka brokers and other buses that we can take that data and we can observe it, and then we can also create conditionals to a rule book to act upon it. So it's that whole acting is where we lean back to the automation that either we've developed from the perspective of a network developer, or in this demo we'll start to take advantage of leveraging AI to develop some of that content for us, in some cases on the fly, so that way we can respond much quicker. And a lot of this is, again, about how do we vet what this automation looks like and put some more guardrails around it. So that's where we start to double click a little bit further. So in terms of having the ability to vet this out, the next problem or challenge is really the skills that are needed. So if we look at the skills gap, a lot of times on staff, we may have someone that's at like CCIE level, that's a network expert, that really understands the network domain that they're responsible for. But it could be difficult to translate like their skill set and make a knowledge base that's accessible to other team members, right? So in order to be able to abstract some of that complexity and make standard operating procedures a little bit easier for teammates, that's a challenge. And then on the automation side of things, as you start to automate and codify those processes that may have been initially developed, by more of someone that's at, the expert level, because there's levels to this. They may not be the expert in creating content, or in this case, from an Ansible perspective, creating playbooks and roles and Jinja 2 templates, and then making those available to use and to consume from others in the automation platform. So that's where you may see, some folks that are really skilled on the automation platform side of things, or creating, the content, working along with a network expert to kind of create like a community of practice or center of excellence, where as those two come together, then you can start to accelerate creating content. Our solution, like moving forward, definitely leans heavy on building those teams, those community of practices, but also starting to lean more on AI to create a lot of this content. And it's not to say that you can't do it. And like I spent a lot of time initially learning Python, and then learning Ansible, and working with complex playbooks that include, constructs like loops and dictionaries and different filters and regular expressions to parse and things like that. And although I can figure it out, it takes me quite a while to build playbooks, that are needing, that level of complexity. So I lean on AI a lot to do those things, because it's really good, in my opinion, for that. So anything that's mathematical, in terms of, structure, filters, things like that, where you're, essentially leveraging, Python code, calling it in your playbooks, it does a really good job, and it saves a ton of time. And then the other thing, kind of bringing back what we mentioned earlier with Event-Driven Ansible, is we can start creating these feedback loops, or what the industry calls OODA loops. So what that does is it allows you to observe, orientate, decide, and then act. And that's really what Event-Driven Ansible is meant to do. So it reads in that information that could have been triggered from an observability tool, or directly from devices, or some other system outside of Ansible, and then to take that data and make a decision, based off of the conditionals that are set in what we call rule books, and then act upon it. So the acting upon it, up until this point, really involved a person, making this automation available. So the configuration would, predate, running one of these operational loops. With AI, we can start to, build things, kind of, create content automatically. So in order to do that, there's kind of a barrier to entry to start using some of these tools. And I mentioned that, you do, obviously you want to put some level of effort into vetting out any of this content that's being created from AI. And there's a skill set, or a couple of skill sets around that, in order to understand, not only do you have a functioning playbook, but is it leveraging best practices, and those types of things, and being able to ask or prompt, for that information, or to express your requirements. There's kind of a skill set just around prompts, right? So you need to make sure that you're not too general. You provide some level of context. You kind of have to know what you're asking for, and then you'll have a better response, or in this case, a better playbook will be constructed. And then the second bullet is really around evaluating the large language models, right? Because there's a bunch of them out there. I'm going to show you Lightspeed today that uses the Watson code assistant, like on the background. And then I'm also going to use a Llama model that I have access to for free from Grok AI. So it gives me like a free API that I can call and interact with. So in the playbooks, we're going to interact with APIs. We're not using like the front end agents, from like a chat perspective or a chatbot. We're going to use playbooks to talk to the APIs. And the reason I used Grok in particular is because it's free. And a lot of these, even when they're free, when you're using their web front end, you'll accrue a charge. So you consume credits, you have to pay for them to have access to the API. So in order to make this programmatic, I'm able to use Lightspeed, which would have a subscription, for customers, but I have that available to me. And then I can compare the results from Lightspeed with using Grok, because I can run both of those, and then I can see a playbook. Or if my playbook fails, then I can have like a series of other LLMs that I can try, and then run them through a pipeline to test them out. So that's where the sandbox is important, because this gives us a sandbox that we can learn how to develop intelligent prompts so we get better answers. And then also we can benchmark those LLMs against each other, or at least to have fallback ones, so we have more than one source. So we can use those to build content quicker and create this whole what I call a pipeline, or a network AI ops pipeline. So this is effectively what you'll see in the demonstration. And I'm just going to walk through this real quick, and then we'll get into the actual moving parts. But before I get into here, let me pause and just make sure there's no questions so far.
No, we're good so far. Looks good. So yes, bring observability, right? Like you said, together with actual remediation, right? Because there's a gap in there, right? You get all this data into Splunk or Dynatrace or whatever solution you have, and then you have separately Ansible or other products for automation. But how do you bring them together? And AI helps you with that, of course, connecting these two domains, and at the same time being able to, like you said, Tony, right, the workflows that a CCA would run to troubleshoot or to architect the network, you can automate those, and those skills, and basically lower that time to resolution, right? Like mean time to resolution.
Absolutely.
Yeah.
So to make this like more real, or something that most of us can relate to from the networking side of things, the use case, or like the problem that we're solving in particular here with these playbooks, is troubleshooting OSPF. So this is not like an exhaustive list of everything you would do to troubleshoot OSPF. It's just some examples. So we're going to go through 3 scenarios that the network expert already knows very well how to automate, or how to manually provide troubleshooting for a resolution that would map to different things that would happen in OSPF. But if they wanted to, again, provide or codify what they already know, and to make it available for others, then in this automation scenario, this is where other folks can leverage that knowledge, because now it's been translated into a playbook. And then we vetted a playbook that was developed through AI, but vetted it in this environment so that we know that it works. So there's some techniques that I'm going to use that would translate to really any use case. It doesn't have to necessarily be OSPF troubleshooting, but it's just a way of running through different playbooks, through different LLMs, getting responses that either work or not, and then being able to to build our content that we can use moving forward into production. So think of this as more of like a staging environment. But with any staging environment, it's important to also hook in the same operational tools that typically you would use in production. So you're kind of working out those scenarios as well. So in this example, we have Splunk as the observability tool. So it's receiving syslog information from Cisco networking devices, routers, and it's providing the log aggregation, but it also has the ability to create events. And from an event, you can create an alert, which is like a notification that can be sent from Splunk to something outside of Splunk. In this case, to the event-driven Ansible. So if we were to take OSPF and break it on purpose, which I'll do in this demonstration, the first thing I do is I shut down the interface between the neighbors and OSPF, so it breaks that full adjacency. And as soon as that happens, there's a syslog message that shows that the neighbor is down, and Splunk will pass that to event-driven Ansible. And event-driven Ansible has the ability to trigger a workflow in the automation platform. So if you're not familiar with a workflow, Really what that is the ability to run multiple playbooks, or what we call job templates, in a particular order. So the first thing that we'll do in the workflow is we'll run a playbook that will connect to ServiceNow and open up a ticket. And in that ticket, we're going to pass all the information that was sent from Splunk to EDA into ServiceNow as part of the description, so that we have a record of why this device is down, and here's the data points that were a part of that webhook. Now, that'll just kind of sit there until later in the process. So we have an open ticket. The next thing that we're doing, and again, this is more not so much for vetting the playbooks, but just for adding the same tools that we'll use in production. Because as things go down, we obviously want a ticket, and even when this whole process is automated, we want to track how long it was down, when it was brought back up, more from like an SLA perspective, but also what was the fix. And then we can determine, and use that as metrics on how well our AI ops is doing, or in this case, our network AI ops. So we have a ticket. So that's a part of ticket enrichment. And then in 4, we're going to request for a playbook. So this is where I actually run a playbook that's going to connect to Lightspeed, to the API. And there's a variable for the prompt. So here's where I had to play with the prompts, because I needed intelligent prompts, again, to state my requirements based off of the context of what's going on in a way that makes sense in terms of building a playbook. I didn't have to like verbatim say, here's every little thing that's in the playbook, but I did need to state certain things that typically are required in a playbook. Because what we want to do is we want to do some show commands effectively to garner some information, or we could, run facts, those types of things, so that we can get some information back from the device. And then we want to act upon that information. So it's kind of a 2-step approach in the playbook. And we have to ask for it, in that manner. Collect this type of information, and then if you receive this type of response, then act in this way. So if the interface is shut down, then we want to obviously do a no shut. If there's something else wrong, if the interface is up, but there's something else wrong with the neighbor relationship, then there's various other root cause possibilities that could happen. And then we're going to look for those as well. So think of things like the actual OSPF neighbor type, or the hello interval could be wrong, or mismatching MTUs, like those types of things. We can systematically look for those and then automate that troubleshooting that typically someone would have needed to have done, manually. So when these playbooks come back, they may or may not work. So we want to test the playbook. So Ansible has a really neat feature that's useful in this type of scenario, where we can run that playbook in check mode. And in check mode, we'll know if it's a valid playbook. And also it'll connect to the device, and we can see the state of the configuration, if it needs, if it's there, if it exists or doesn't exist, because Ansible is idempotent. And we'll see all of that in check mode. So that's where we'll either have a good indication that it's a good playbook, or it's not going to work, or it's not working the way that we expected. We may want to try like an alternative. So in my workflow, I can try the second option, which is this Llama 4 model that kind of got cut off this slide. I don't think you can see the whole thing, but you'll see it in my playbook. I selected that, and there's other models that I could just change the variable, and it'll try, additional models. We could extend the workflow to try, 2 in this case, but it could be a half a dozen or a dozen different models, and we'll have all of those playbooks that come back. But what I'm doing is with Lightspeed, if it works, if it doesn't work, then I try my second option. And then that's where the human approval is. So there's still a human in the loop, so that, I've seen that it's a working playbook, what we expect it to do. And then we're waiting for that approval. So in the workflow, we'll either approve it to run or deny it. In this case, if I deny the first one, it'll move to the second option and create another playbook. Or you could just cancel the workflow in its entirety. As it approved and moves forward, though, it's going to run that same playbook in run mode. And in run mode, it's going to actually remediate, in this case, either no shutting a port, or changing the network type, or changing the hello interval, whatever it needs to do to fix the situation. And as that OSPF neighbor comes back as a full adjacency, then we close out the ticket. So that's where we communicate back to ServiceNow. And at the end of this, we'll go look at ServiceNow, because you'll see like the time that it was open, all the details that happened in between, and then actually closing the ticket. And then ultimately, like in your observability tool, you should have fully functional OSPF, working on the front end as well. So again, this is more of a way to build the playbooks and also test it in a way that's similar to what it would be in production using all the same tooling. So with that, I'm going to go into the automation platform, or actually I'll go into Splunk first and kind of give you a lay of the land of what you're going to see before things, start moving and reacting. But before I do that, again, Adrian, is there any questions or anything? Any comments?
No, this is interesting. I'm more interested on that step 5 when you actually get the prompt and you pass it on to Lightspeed and it goes to Grok. So that's the piece that I'm really curious to see.
Okay.
But
So
here, could you zoom in like a couple of times, Tony, please? Like,
sure. How's
there you
that?
go. Yes, that's much better. Thank you.
So at this point, and where I'm at is there's different applications in Splunk if you're not familiar with Splunk, and this is for Cisco networks. So in this app, there's a couple different tabs here, and I'm in the routing section. So this is just receiving syslogs from the devices, and we can see that we received one from this particular router. This is the one of interest that we'll check against, and it's up and running on tunnel 0, and it has a full adjacency. So that's kind of the state of where we are right now, the current state. Now, if something happens, this was the feature in Splunk that's very useful is the alerts. So if I go into the alerts, you can see that I set one up previously called OSPF neighbor.
Mm-hmm.
And if you look and open and search, this is what I'm looking for. So if I receive a syslog that has this OSPF 5 adjacency change, if I see that go down, then that will trigger the alert. So this is just, this is like the internal trigger for Splunk, not the trigger in EDA, but this is like where Splunk says, okay, now this is something that I need to act upon. And I'll go back into the alerts to show you what it'll do. So if I receive a syslog that's down, right? So that one that you saw earlier, we're in an up condition, but if we're in the down condition, then this would happen. So here it's going to create this triggered alert, and it's going to leverage a webhook. So this one here is just a simple webhook. I think I have to go in here to see it. Yeah, this is just a simple webhook that's going into my lab environment. If I wanted to also wrap authentication around it, I would create an event stream on EDA. And then on the front end of this, you go into the apps, and there is this new section here for event-driven Ansible. You would create one in here that would map to your event stream. So you would turn on different types of authentication, those types of things. So this is where you would go to configure if you wanted to add like those additional capabilities. Splunk also allows you to use Kafka, which is another way of passing data through a topic. And we have a source plugin in EDA for that as well. And that's set up in here too. But I just wanted to just kind of show you this in passing, but just know that this is where you would go to make those changes. So that's pretty much the Splunk side of things. Let me go back because we'll come back to here later. So you don't have to wait for me again. Just go into
Cisco Networks.
Yeah, I'm going to go back to like the main page of the Cisco Networks. This is kind of like the main landing page. And then I was over here in routing in this dashboard. And we'll probably return here later just so you can see that it's down or whatever the state is. So that's where we sit there on the Ansible side of things. And just bear with me a second. For those who haven't seen this is the Ansible Automation platform. It has a unified GUI. So everything you see in automation execution is the automation controller, or what some of you may have known as Tower in the past. This is where we manage the automation. The EDA part of it is under automation decisions. So this is all run just like we have playbooks for automation. We have rule books for event-driven Ansible, and how we have job templates are tantamount to these rulebook activations. So job templates manage how you run playbooks in the automation controller. And then these rulebook activations are how you'll run the rulebook. But the difference is the rulebook is always there and running. Where in automation, you launch it, right, when you're ready, or you schedule it to run. This is always sitting here listening, waiting for data to come in, and it keeps a history as things happen. And the state that it's in right now is it's just sitting there, and it's just listening for OSPF neighbor events from a webhook. So it's just sitting there. As soon as it receives one, it's going to run a workflow in the automation controller. So we'll kind of set this up here to jobs, and we'll see when that happens. So let's see, get rid of that. And this will just be like any of the jobs that run should show up here. So we'll come back to this in a second. We haven't broken anything at this point. So if I go into the router, and
OSPF neighbors or something, right?
yeah, we want to make sure that it's up and running. If you recall, Splunk saw it on tunnel 0.
Yeah.
Right. So here's the neighbor that it was, it also showed the neighbor on the dashboard, this 192.168.3.3. It's in a full adjacency. So if I went in here, and this is like the first scenario, right? We're just going to do this, shut. So I shut that, and then obviously that's going to break the neighbor. Actually, I got to do a do
show terminal monitor or something, or IPO.
I'm just going to show that it's not there right now.
Yeah.
So it's down. And then when we go back to here, you see that a job started, and it created this workflow. Now you probably can't see this, so let's make this a little bigger. So where we start here is we're going to create a playbook using Lightspeed, but we also opened up that ticket, and this isn't very important. We'll come back to this later, but this is just for tracking purposes. We opened up a ticket, and we're creating a playbook right here. So if I go into here, it's going through the motions of interacting with Lightspeed. So what it's doing, and I have to show you the playbook so that you have the context of like how we set up the prompt. But this is sort of, I guess, this is the playbook that it came back with. So the prompt had like the 3 scenarios in it. And the first one is, if we have a condition, so I set up some, asked it in a way so that it would set up conditions. If it sees that it's administratively down in the output, then it's going to respond with a no shutdown. It's going to try that. Now, if it's up, then it's going to continue down to these other scenarios that we'll talk about a little bit later. But this was all a result of the prompts. Sometimes I do this where I just do one prompt at a time, but it takes a bit longer. So I just went ahead and built the entire playbook. So the playbook itself, this is probably the easiest way to see it in here. This is just like my local Git repository. So just think of it as kind of like a GitHub. If I go into this one and click in EDA, and just refresh it, just make sure everything's So this is the actual playbook that it created. In the playbook, I actually will delete if there was already one there, and always building a new one. So yesterday, you can see I did one from the Grok standpoint, but we're going to do one of those here too for you, Adrian, so you'll see a new one in there as well. So this is the playbook itself that came back, just like we saw on the screen. So the other playbook that's interesting is like, how did we ask and prompt for this? So that's this one here, this AI ops. So this is just a variable, and I could have put this anywhere, have it in the playbook itself at the play. I created this prompt, and there's certain things that I needed to explicitly add into this, like what host do I want this to connect to, because I have all these different routers in my inventory. So I wanted this one to be the Cisco router 1. So I told it that explicitly. I wanted to call the playbook. The name will be OSPF fix. And then I'm telling it, create a task. So I'm using like kind of the playbook language. So create a task that shows the status of tunnel 0 and register the output. And then the next task is, in this new task, make sure that you go into the parent, which is the tunnel 0, because that's the interface that we use for OSPF, is the tunnel interface 0. There's also a tunnel 1 that's a BGP connection. So we want to make sure it's the proper interface, we could have added like additional commands to figure out, which is like show IP OSPF interface to figure out which one it is, that kind of stuff. But I just went ahead and told it. And if it contains administratively down, then you're going to run another task to make sure, that's the no shut part of it. But if it's up, that's how we, move further down here. If it's up, then it could be different things. So long story short, the two things that I mentioned was, if you had the correct network type, which should be point to point for this one, and the correct hello interval should be 10. So if we change that, that'll break the neighbor adjacency. I could have did like MTUs and a bunch of other things that could break OSPF and just make different, tell it to make different conditions for us based off of those. So here's where it's a little bit different depending on what you're connecting to. So this is what it looks like to authenticate and and ask through a prompt with Lightspeed. This was different, a little bit different than the Grok, because that's kind of the issue with a lot of these connecting to the API to these various models. They're front-ended with different authentication and things like that. So depending on which one you're dealing with, most of the time you do have a token of some sort, but your URL or URI module, you might write it a little bit different, depending on what you're connecting to. But they usually give you like a curl example, and then you can just ask their AI, convert this into a task for a playbook, and then you'll be able to interact with it. The rest of it works, effectively the same way. You're just going to have a response that comes back. You want to turn that into YAML, and then you want to save it to your repo. So that's what this module is for. This get retrieve is part of the SCM, Ansible.scm is source control module. This is the same thing as like a git clone. So you'll pull down what's in the repo, and then I wanted to remove any old information and then pull it back down again. And then I'm saving only my YAML file and publishing it as the same thing as like doing a git push into that repo. So now you have that updated playbook like we saw in the repo, and it's available and it's ready to run in the environment. And I mentioned we're running that in what we call a check mode. So if we go back into here, into the jobs, and I'm sorry, it's going to be small again. I'll have to expand it out. We should just be sitting here at the human review. And what we need to do is check this check mode, because we actually ran, this was the playbook. We actually ran it based off of the condition that the router is in right now with the shut interface. And this is the playbook that actually worked. But if we feel comfortable with it, we can approve it and we'll run it again in run mode. Sorry, it kind of goes way over here in run mode. And then if that works, then we'll close our ticket out. Now, the other avenue or different conditional we have here is if it failed, then I have this red line, right? So if I don't approve it, I can deny it, and deny will go to the red line. So it'll run on fail. And I'm going to create another playbook using Grok, which uses the Llama 4, and then it's going to check it, and then I'm going to approve it, and then apply it that way. So I have, I could like keep doing that. I could add more of them. So it either works, it doesn't work, then I try another one. So in the early stages, maybe I have like a handful of these. I'm just trying to figure out which one works the best based off of my criteria, and also playing around with prompts too, to make sure that I'm asking it in a way that makes sense. So how I know this happens, because it's supposed to be, AI ops, is I set up a notification here for this, this step. This is an approval step. So in here, we receive this to our, our network team, receive this, that we need to make an approval and review a playbook. And then this is like a cross link back to that workflow, to that step. And then, it's just we're opening a ticket. It's just a notification. There's many different types of notifications, just a way to make people aware that, something happened in your workflow and it needs additional attention or review. So in here, and what's important is we go into here, and here's what happened. The first part of it was showing like the status, right? And we can see that it's administratively down, line protocols down. And that was a conditional to say, okay, when that happens, let's just, no shut, right? So it went into the proper interface and it did a no shut. Very simple playbook reaction, but it was based off of that condition. So the next thing that could happen, and this needs the approval still, right? So Just real quick before I forget, it's still down, right? It was check mode. It didn't do anything. And then I go back into here, into the job, to the workflow. And sorry, that keeps getting small like that because it has so many steps. Blah, 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 blah. This guy here.
Human review, yeah, and you can approve it, right?
Yeah. So now it's going to run it. It's going to no shut it. It should all come back. You see the little note. I don't know if you see that on the screen, but I have like a little pop up with a notification.
Mm-hmm.
But if you don't see that there, it's adding another line in here and like the job number and all that stuff. So we have a new job number for running it, and that's what it's doing, or it actually already did that part. So it's closing the ticket right now. All right, so this whole workflow completed successfully, and then go back to here, right? And we have our OSPF neighbor back. So that was just the one scenario. So the other one I mentioned was the network tie. Or actually non-broadcast. The only problem with these is it takes a little bit because of the dead timer. So it won't immediately go away. Oh, actually, that did go away. Sometimes I guess it depends on where you hit it at. Sometimes it takes seconds. Yeah. All right, so so that one went down. So I should expect like another reaction, right? So it kicked off again.
So, Tony, I mean, the prompt building, that's pretty descriptive, right? And you have it like, okay, do this, do that. How far away are we from just feeding the syslog message into the prompt and the LLM to figure out like all the steps?
Yeah, so like to translate to, here's the syslog that came in.
Yeah.
It says this interface is down and all that kind of stuff. Build a playbook. So one of the things that we need is there's all this other component, right? Because we're just dealing with the LLMs here,
Mm-hmm.
that part of it. So we have to know information. We're telling it like this router, this interface. We understand what the state is, or we've collected the state, from something that's outside of the AI. The AI also has like the MCP servers. So with those, they give the ability to interact with like devices or other components like AAP as an example. In not in this version, but in 2.7, there's supposed to be like that type of integration where the MCP server can communicate or like run what we would call like controller as code commands, like use the API of the AAP to see like, okay, what's in the inventory, what devices, what playbooks do you have and job templates, all that kind of stuff. So that's kind of teed up. So that way I don't have to build like the workflow from scratch. Like I did here, I had to, build all that stuff manually.
Yeah.
The only thing that we used AI for was the playbook, but like I had to like create a placeholder to run that playbook, in my existing workflow. So like in the future, that will be like, a requirement. Okay, here's a playbook, run the workflow. Now to create the playbook, we would need some context from the devices. So we need MCP server that has the ability to interact with like the Cisco devices. And that's kind of like productizing that is like something that Cisco's already doing, like other vendors too, where they're providing like, access to that state of, different solutions. And there's either like REST API or command lines or whatever that happen behind MCP. But the abstraction is that on the front end, it's just an API. So like effectively, like the workflow could just be API calls that are made, and the playbook could be constructed from context that's gleaned, from those servers. So we don't have to have the front end human, doing all this work up front. It could happen more in real time. But I think you still need that human in the loop though before you like apply the remediation, just to like have somebody just, for the time being, right? Have somebody still that like looks at the end product before it gets deployed and gives the thumbs up. But you can make it a lot quicker, right? Because here you don't see the time that was put in developing a workflow, but I had to do that. And I had to do quite a bit of Ansible things and like build, configs on the routers and things like that too, that could have been completely automated. So the whole thing with that webhook that's coming in that says my OSPF is broken, having the other context like, oh, it's on this router that's connected to that router. So tell Ansible to run it only on this router, on this interface, like all the things that we had to express explicitly, all that stuff should just be derived, from the MCP part of it. And I think that's where you start getting more to the agentic side of it. But, that's like still, not to say that it doesn't exist, but it's like still like at this level of complexity, it's still a little bit further out, to have something like a solution that just does all these things. I think it's going to be like a combination of different, solutions together to be able to orchestrate that stuff.
Yeah, because it feels like a bit hard coded now, right? Like the whole thing. And then with MCP and AI agents, you can add some variables into it. I think you can think of it that way, right?
Yeah.
Instead of
And
having,
like from
yeah,
Ansible, we have like the whole gathering facts kind of notion.
yeah,
Like learn like the state of the config, or like doing assertions, or using something like PyATS and tools to like see like what the operational state is.
hmm
It's like having AI's ability to see those things. Then it could derive a playbook that makes more sense, based off of like the existing state of what's going on in the environment.
yeah,
Because we have to do a lot of work to find those things out, or in a workflow to check things, or I might need to sync back to my repo, do all this stuff because we're learning as we're going across. So, so this one was the second one where we changed the network type. So you can see when it ran the show command, right? So in the playbook that it constructed, it came back and it sees that the line protocol is up. So now it's going to check, further conditionals. And in this one, it saw that the network type was wrong, right? Because it's not point to point. So it's just, that's all it's doing. It's kind of like like a tripwire. It's not in compliance, now compliant. So the complied config would be the IP OSPF network point to point, and then it applies that one. So so the third one example is, well, actually, let me go ahead and run this through real quick. I'm just going to accept it.
If you have to approve it, and then it's going to go and remediate basically.
Yeah, so I'm going to go ahead and approve this time. On the next one, I could fail it on purpose so we could see it go into action with the second model.
To go to Grok and Llama.
Yeah, so let's go ahead and approve it. Oh, I forgot to do this real quick.
Quick, let's see.
Yeah, so it's not there. All right, so let it run that playbook, and then it should come back. Or actually, see where. Oops. Where am I?
And the ServiceNow tickets, Tony, you were saying that that's important too, right? For tracking purposes.
Oh yeah, let me. Well, I can grab that from this one because since it finished. All right, so we just finished fixing it. So here's the local check, and we could look on Splunk too, right? So it's back.
Yeah.
And so the ServiceNow part, I need that ticket number. So let me grab that. And I'll probably have to log in. ServiceNow has been kind of sitting there a while, so just bear with me a second.
Mm-hmm.
Sorry.
Hmm. Did they close your account? Hopefully not.
Let me spell my name right. No, it was working earlier. It is there it goes. I forgot the bang. I was putting a 1 instead of a bang. Okay. And then that incident number should still be in there. I'll click in here. Yeah, it's kind of just a little slow. So this is what was sent into ServiceNow, was a description of what, initially it opened it. We're looking at the closed ticket. And the open ticket was this first description where you can see that the OSPF neighbor was down. This is all the data that was passed from the webhook.
Mm-hmm.
So like to your point, instead of just sending this to ServiceNow, we could have sent this payload, as a prompt and say, this just happened, fix it. And based off of what's included in here, because it does give you some information on like its IP address and host, because that's a part of the syslog. So some context, there might be enough context that's actually a good idea. I'll try that. There might be enough stuff to build the playbook just from this.
Yeah, exactly. I'd give that a try, right? And I give that a try also to see if it learns. So, because you already ran, right, the prompt, the descriptive prompt with all the steps, right? So you told it do this, check the interface, check the network type, right? Check the MTU, whatever you want it to do. But so it learned basically. So then if you switch around and on the next run, you actually provide this payload and see the LLM, right? If it actually figures out, and also if it learned from the previous prompt that you had passed, that'd be really interesting to know.
Yeah, that's a great idea. Yeah, so this will live on with phase 2. I'm writing some of this stuff down too. Yeah, because like the real context of state and all that stuff that's coming through servers, the MCP servers, but like you may not need that much. So you can get a good bit of context from the data source, from the event-driven Ansible, as it's passed through into the prompt for the playbook. Because in EDA, you can create variables and you pass them to the workflow as extra variables. So this is just like another extra variable comes in and that feeds into a prompt.
Yeah.
So the other thing here was just that it closed out because the adjacency is full, so it's just not a whole lot of detail there, but like just, when it was open and it's closed, if this happens automatically, then you can track like down here your SLA times and all that kind of stuff. So it was down for 6 minutes, that kind of stuff. So back here, just the third scenario, we'll go ahead and try that, see how it does with the other model. So let me show you how that looks first before we kick it off. So if I go back into the playbooks, this is the one that will create the Grok playbook. Now, this one here, I use their AI to take my playbook and like mess with it to change, like, what do I need to do to interact, with their API in particular. So that's why it looks like this. Is just like what their responses come back, just the default way that they comment on things and stuff like that. But the prompt is the exact same. This part, asking exact same way. So it's, apples to apples with like the playbook response. And then the actual connecting to it was different. So obviously, the URL is different, but also just the way that, it's providing authentication. I needed to like interact with it a bit directly just to see, okay, give me an example of how to connect. And then once I did that, and I had to obtain a key. And that was a big part of this. If you're just trying this stuff out, you don't even need AAP to try this out because you can just run these playbooks, but you do need a key. And then like I define my key in credentials in AAP, but you could use like Vault or something. I would, definitely don't ever put your tokens in your repo, right? So you want to put them somewhere outside of your project or encrypt them, right? Or have them, stored in the automation platform if you're using that. But you have your key. And then the rest of the playbook is similar, where we're getting a response back, and then we want YAML format, and then that's what we're effectively we're publishing that back to the repo when we run this. So we saw earlier in the repo there was an older one from yesterday, so we'll have a new one this time around. So to kick this off, I'll need to go into here and break it again. So we're already.
How should we break it this time?
So this one is going to be the hello timers.
Okay.
And then I think it was 10 was like the default. So really anything that, put something up or, was 10. I'm going to do 40 just in case. Different types of interfaces have different hello intervals, but I think that one was 10. And then this one might have to wait for the dead timer. Unfortunately, this time we were into like 20 something seconds. So wait for it to go down.
12.
10.
10.
Isn't this exciting?
And is
Gone.
gone.
Yeah, dead.
There you go.
So the dead timer works, right? So that does work. So just like before, it should kick everything off here in the jobs. But this one, I want to get the workflow, get there kind of quickly so that we can deny it. And then we'll go to that second work stream in the workflow, which went down to the building the second source. So like if we go in here, let me make this a little bit bigger. When I deny, it's going to drop down here and create a Grok playbook. And then it'll run that in check mode. Another thing I was doing is I was just running them at the same time, but then I was kind of like accruing a lot of tokens. So I didn't want to make sure that I didn't exhaust that. So I only run it when I need to. Different in Grok, like different models have different, how many of, limits on how many of them you can run in a certain period of time and stuff like that. But we'll see the answer from this one. And it will be similar. Like it's really close. The El Llama does really good for Ansible stuff. Yeah, so now we're here. And I want to deny this time. Go back here. And so now we're into creating the Grok playbook. All right, so it finished the playbook. And so it's going into check mode. So we should see that in our repo. So it'll be this Grok response one. See how it says now? So this is definitely the one that we just did. Right, and you'll notice that from first glance, it looks a lot like the one from Lightspeed. We could do like, diffs and stuff against them to see if there's anything different, but nothing strikes me as like being way different. So it should work in theory. So we go back to here and we can see that it made it through its check mode. So this one says check the status. The tunnel was up, so it goes into looking at the additional stuff. So see how like it went down to this task for the hello interval needs to be modified. Right, so it was 10. I couldn't remember, but it was 10 for that type of interface. So it changes it back to that. So I feel like, that's a good fix. So go back to the workflow. And we're sitting over here waiting. Approve. And you can hit these approvals from APIs also, or things, other tools outside of AAP, like a ServiceNow or, something like that. And then it's going to run it. I guess I should jump over one. I should jump back here just to see. I guess it already did it. I wasn't quick enough that time. I forgot to. Yeah, because everything's done. So, well, actually, I just instead of going into there, we'll look for this is the one where in run mode. And when I say run mode and check mode and all that, if you look in the details of the actual job template, that's defined in the job type. So this one's run. If it was in check mode, you would just change this to check right here. So if you're used to running Ansible playbooks from the command line, these are all the same things that you run just as arguments when you do the Ansible-playbook command. So it's just all in here in the GUI, and you have access to it from the API and controller module as well. So this one's done. So we go back to here. And well, yeah, I already saw that part. And then we haven't really went back to Splunk, but like it's the same thing. In Splunk, I should be able to refresh and see that it's in there.
And it should be full again. Yeah.
Yeah. So so that was the example of using the different LLM, and it gave us similar result because the playbooks came back effectively the same. And my prompts were in the beginning, I did have to play with them a lot. They were more general. and I did have to make them more specific to get like a consistent result from like multiple LLMs. But to your point, like trying to pull something, you know, from data and convert like the webhook data to the prompt, that's really interesting. So that's next on the plate to hopefully
That'd be
improve this.
interesting.
Yeah, that'd be pretty cool.
And then did you do a diff between these two playbooks? For example, Tony said they were exactly the same, or they're a bit different compared, like Grok compared to
I don't know if
Lightspeed?
they're exact. I don't have that like a task to like to diff them from Ansible in here, but we could try to see from in here.
In GitLab, right? Yes.
So we know how to
That'd be
do like
interesting to see. Like,
well, I could put them. I could put them next to each other real
side by
quick.
side.
Yeah.
Yeah.
Duplicate. So this one, which one was this? This is the Grok one, and then this is the Lightspeed one that was 5 minutes ago. All right. So, oh, I'm sharing the window. So when I split these, I think you won't be able to see it that way. All right, so that's Grok.
Interface tunnel, okay.
Not the best way to do this. I can do the history one, like I know how to do that diff. They're doing the two different files in the git t. I'm not sure exactly how to do that. I could do it from locally. Oh, that's how I do it. So locally, let me make sure. Let me get into my local repo right here and do a git pull. Make sure everything's good there. So it already was up to date. And then I've got the playbooks and here. So this one is the Lightspeed one. Oh, that's to make the playbook. Here's the response. So Lightspeed response and select to compare. And then Grok response, compare with selected.
All right.
So this one didn't turn off the gather facts. This is the Grok one.
Yeah. Show interface status, and it has the register output Cisco iOS commands. Okay, interesting.
Oh, this one didn't do the fully qualified collection name.
Huh.
This is the Grok one, right? I'm getting confused. This is
No, the Grok one is on the left, right? Oh.
No, this Grok one
No.
has doesn't have the fully qualified. It's
Interesting.
yeah, Lightspeed is this one. The one on the left is Lightspeed. The one on the right is the Grok.
Then show IP OSPF.
Yeah, because the left here, see how it says Lightspeed on the left and Grok's on the right. No shutdown. Yeah, it's because they use different nomenclature, then it drops down.
Then it does a show IP OSPF interface tunnel. Then it changes the lines, the network type to point. That's both of them.
Mm-hmm.
Then the hello timer. Okay. So it's pretty much the same. It's just the fully qualified module name is not in Grok. Interesting.
Yeah. And it works because we include, like iOS is included in like our out of the box. We have certain execution environments that are out of the box. So the like the default one includes like iOS. So I think it can still find it, but a lot of the ones that you have to add, if you don't include the fully qualified name with the namespace, it won't be able to find them. You'll get like an error when you run that module. It'll just say, unable to find module. It'll be pretty clear that, you need to either call it specifically or you're missing it. It's not installed locally or it's not installed in your execution environment if you're using AAP. So it's not best practice. So that's definitely not a best practice thing because it works for now, but at some point this playbook could go sideways. So I guess like that's another step too, is for these secondary ones, like kind of guess using the one as a standard and then seeing what best practices it deviates from. But it from like a functionality it worked, but from a best practices, like it needed like a lint step to catch this. So let me write that down too.
So
we need a webhook driven prompt that's lint checked.
Yeah.
Compares and diffs and do a diff between the responses that come back, the playbook responses.
Yeah. And did you have a chance to play with Claude as an LLM yet?
Yes. I was using Claude desktop on Fedora because my laptop runs Fedora. And I got that to work from the desktop. I was just trying to, there's a couple of open source MCPs, like one can connect to Cisco devices, another one connects to AAP, that are just like Python, MCP servers that folks wrote open source wise. But I was having some problems with the config in Claude where it's supposed to give you like a little hammer icon when it detects that the MCP server is there, but mine doesn't work yet. But I can do all the LLM stuff. I just can't get the MCP stuff to work yet.
Gotcha.
But I just started messing with it like a couple of days ago. So I think it's easier if I do it in OpenShift, because in OpenShift AI, there's like operators and easier ways of deploying the MCP servers. So I might try that instead of using my laptop, because a lot of stuff in Fedora doesn't work the same as RHEL. So
right. Yeah.
So it's easier like to do the Claude stuff in Macs and Windows, actually, I think.
It is. It's quite a bit easier, especially on the Mac. All right, Tony. Well, this is fantastic. So just a recap here, right? Building a pipeline. You got your syslog data coming in from the network devices. They're fed into Splunk, Dynatrace, whatever you have. In our case, we've had a Splunk instance, right? The syslog gets into Splunk. A webhook gets triggered, right? Something happened. It's an OSPF neighborship, is an interface down, is a BGP neighbor, whatever it is. Whatever it is, you get that, you generate a webhook event from Splunk, and you send it to your Ansible EDA, right? You have your Ansible automation platform is listening for that webhook, right? Intercepts it, and then goes and looks over the rule book from the event-driven architecture. Is that right, Tony? Right.
Yeah.
So it looks
in the
over the
rule
rule
book,
book.
I didn't really show you the rule book, but like as part of the rule book, it's triggering that workflow. So like it automatically triggers that workflow, but I had to manually create that workflow ahead of time to say, do the thing where you create a playbook and test the play, like all that stuff was pre-configured in a workflow that because of the condition, because that webhook came in and it was an OSPF issue, it runs this OSPF fix workflow, and then it had all those steps in it.
Right, and you can have multiple workflows based on, you can have multiple webhooks, of course. And then you also create a ServiceNow ticket, right, just to keep track of things. And then the workflow basically went ahead, looked what the status is, and then ran those prompts that you've built against Lightspeed first, right? Lightspeed returned the playbook. The Ansible playbook is like, okay, this is the playbook that you should run to fix your issue, which could be, checking the interface status, checking the network type, checking the hello timers, whatever else you want to add in there, MTUs, like you said, and so on and so forth. Gets that playbook created, and it returns to you, and you're at the stage where you have to approve that that playbook basically to be deployed. So you have here the manual intervention, right? Slack message is sent. Hey, there's an event that you need to approve. You go, you approve that playbook, right? In the workflow, it gets to the next stage, which is connect the device, applying that playbook, fixing your issue, closing the ServiceNow ticket. If everything went well, and you have your network back running again, and it's practically all automated, right? So this is all of it. The human intervention is just like, hey, you want to approve it? We've created a playbook for you. We've tested it. We run it in kind of like check mode, right? we know it's fine. Now, do you want to actually go and approve it? So the person, the actual human, just it's yes or no. And if they do no, then okay, I'm going to the Grok model, or I'm going to a different model, LLM that, Claude, whatever else it is, and go with their playbook.
Right.
But yeah, this is really cool.
And what we learned today is that Lightspeed was a little bit better at the best practice part. So I
Yes.
can test it for functionality, but like best practice wise, when we did the diff, we saw that it wasn't
Yeah.
using like the fully qualified collection name. So that was something like a lint would have complained about
Yeah.
sooner. So like adding a couple more steps in that pipeline to catch those things. Because like as a human, right, I'm like, yeah, it worked, it looks good, but like I didn't, in my mind, didn't catch that in the playbook task when we looked at it in the repo.
Ideally, yeah, you would have also like a best practices from like your company, right? Like your enterprise. Hey, the playbook should have, right, fully qualified domain name, should have roles, should have, right. So you, as you set up your Ansible environment, you should build a set of best practices and make sure that all your playbooks are adhering to those best practices, and you can have that part of the pipeline.
And then the other side of this too is like this was like, the concept was like this was like a staging environment where we're creating the playbooks and iterating through using these AI tools. Once we landed on a playbook that works, that went through like this whole cycle, then that could be promoted into like a production where we're not like talking to AI. We already have like the playbooks, so it's like we're just creating like our golden standard for like our playbooks that we know work, and like leveraging AI to put those together. But in the future, when everything's agentic and all that stuff works, then like the production part could leverage AI as well. But I'm not saying like go out there and throw AI into automatically troubleshooting all your remediations currently today. Like vet that out in your staging environment.
Self-healing networks, practically that's what we're getting to, right? Finally, we've been talking about self-healing networks infrastructure for many years. So we're at a point now where, right, exactly, with these simple demos, with whatever monitoring tool you're using, whatever remediation, configuration management tool you're using, you can bring them all together and automate the whole process of troubleshooting, of fixing infrastructure. So this is really exciting.
You're at the precipice. It's like we're right there, so it's so close where self-healing will be a reality.
Yes.
But then it's just like scale and other things. So there'll always be like layers of new complexities to deal with to secure all this.
Oh yeah, so it's not like we're gonna be out of the job anytime soon.
No. There's always that next challenge.
Yeah, no, this is actually gonna be super helpful, right? Because it's gonna help a lot initially with just simple troubleshooting, right? I want to make sure that, hey, run these pings, for example, or curls, to make sure that it's not like a routing issue. And then you go and then you actually bring the experts was like, okay, we've tested everything, right, that we can think of with AI. Now you come and figure out and fix it. And then once they do that, you can just add it as another step.
Yep. The
to your
knowledge base
workflow.
grows. Yeah. So all those lessons learned should
Yeah. All right, so we've run actually a bit over time here. Michael, thank you guys. The more I'm exposed to, the more powerful I realize Ansible can be. Indeed, thanks for watching us. Thanks everyone for being on the live stream. And Tony, thank you so much for showing us your demo. This is fantastic. Recorded. And any final words from you, Tony?
Not just thanks for having me and help giving me these ideas, right, to improve the demo so it'll iterate and get better too. So this feedback's been awesome, and it's always a pleasure to be here on NetGroup.
Definitely, always a pleasure to have you. We'll see when we come back, maybe with 2.7, right, with some new features down the road.
And 2.6 just came out for those that are Ansible customers. That is release if they're not aware.
Right, so it was like a couple of days ago that it came out, right?
So a lot of folks are like doing the upgrade from 2.4 to 2.6. It makes it like a easy process. So that was like one of the main goals, to help those folks get to unified GUI and all that stuff.
Yes, so 2.6 folks, right, start looking into upgrading. bunch of new features, I'm sure, around AI. There's like a AI assistant type of thing with 2.6,
Yeah,
right,
built in.
Tony?
Yeah.
So there's that also that's gonna be interesting. And with 2.7, like we briefly mentioned, it's gonna get to MCP, agentic AI, those types of use cases coming up.
Yep, more to come.
All right. So thank you all again so much. We'll see you on next week. We'll bring Edward Luhar. We'll have another AI-based session. So looking forward to that. He's using A2A and AGP and like all these protocols to build agents for like also fixing troubleshooting networks. So we'll see a different approach.
Nice.
From somebody that has a different set of ideas. So it's going to be interesting. All right. Thank you all for watching. See you folks on the next one.